The next step is, since we want the system to run for 24 hours, and just kind of think about your water distribution system. We know that like during morning hours and during evening hours, the water requirement is more compared to afternoon hours. So it is not a good idea to design a system just for fixed demand, because the demand keeps changing throughout the day. So for that, we want the system to be flexible enough to accommodate different demands during different times. And to do that, we create a demand pattern, also called global demand factors. And in EPANET, we again go to patterns here and click on add. And the first thing that you need to note here is, so you can definitely assign any pattern ID. Let us call it 1, since we want to assign the first ID pattern 1 to all the nodes. And we also know that junction J12, which is here, it was given a pattern ID 2, because the demand for this junction is kept constant throughout the day. But if you look at the question problem, you'll see that the demand factors are given after every 2 hours interval, and here the time period is 1 hour. So we need to change this thing first, and to do that, we go to options and we go to times and edit. We want the pattern time step to be 2 hours. And if I go back to the pattern now, you'll see that the time period has changed to 2 hours. And here you'll still see the numbers to go from 1 to 12. This is just a time step. It does not mean hours. So for the first time step, the multiplier is 1, and in the next time step, the demand factor goes to 1.3. That means the demands across the junctions increase. And you can keep adding these. This is 1.54, 0.57, 0.75. And if you want, right now we are already at 24 hours, you can always add one more time step just to complete the entire 24-hour circle. Click OK. And since we already assigned this pattern to all the nodes, like if you look at J7, the demand pattern is 1. So the demands at junction J7 will get changed according to the pattern that we just provided. But we also know that for junction J12, the demand has to be constant. So we need to design a new pattern for that. I'll call it pattern 2. And for that, the multiplier will remain as 1 throughout. This is the pattern for J12. So now the demands are set, almost everything is sorted. The final thing that we need to design in our network is a pressure switch. So that means that initially we have this low power pump 7 working when the simulation starts, but we want that when the node J13 head goes below 240 feet in the simulation during some time in the day, then we want this P7 to switch off and pump 25 to switch on. And when the head goes above 270 feet at node J13, we want the pump P25 to switch off and pump 7 to switch on at that time. So we want to build that kind of condition in our network. And to do that, we go to controls and we add a rule-based control. I click edit, and here you can add as many rules as you want. But there is a fixed format to add the rules to a system. So this is how we need to write the rules in our network. So we write rule number and then go to the next line, and what we want is if junction J13. So these are the statements, but this one is the junction ID. Like if you name junction J13 in a different way, so you have to write this name corresponding to however you have named it. Head less than 240. We do not need to add any units because the system already knows what units we are talking about. Then pump PU25, again the same pump ID, status is open, but we also want pump PU7 to get closed, and for that we write an AND statement, and pump PU7 status is closed. So this is the first rule. Whenever the head at J13 gets below 240, we open pump PU25 and close the pump PU7. And also recall that initially when I was writing the properties of the pump, I closed the pump initially. So that is what was required in our problem. But we also need to add another rule, because when the head goes above 270, then we need to switch the pumps, which means pump at that point, pump PU7 is open, and we want to close pump PU25. So note that the rules have to be defined with this formatting only. You cannot write the rule like this. This will give you an error. So every statement of a rule has to be in a new line. So now we have defined all the properties of the network. We have defined the rules, we have defined the curves, we have defined the demand patterns, and we hope everything is done okay.